Storage allocation methods can be broadly categorized into two types: static allocation and dynamic allocation. Static allocation: the allocation of memory during compilation time. It is not possible to change its size during runtime or execution time. The allocation remains unchanged throughout the lifetime of the program or system. Characteristics: fixed size. The size of allocated memory or disk space is predetermined and remains constant. Deterministic. The allocation is determined in advance, and the same amount of space is allocated to each process or data structure. Compile time or system startup. The allocation is performed during the compilation stage or system startup, and it does not change dynamically during runtime. And there are some drawbacks. We have to know the size of the array in advance. Memory waste. More memory is allocated than required. If less memory is allocated than required, then it's a problem. Insertion and deletion operation are expensive because of shifting each elements. Static allocation is commonly used in embedded system, real-time systems or system with a strict resource requirement. It offers simplicity and predictability but may lead to inefficient resource utilization if the allocated space is not fully utilized. An example for static allocation is stack storage allocation. The stack follows a LIFO order, where the most recently allocated memory is the first to be deallocated. The size of the memory allocated on the stack is fixed and determined at compile time. Deterministic lifetime. The lifetime of stack allocated memory is deterministic and directly tied into the execution of the corresponding function or block. Fast allocation and deallocation. Allocating and deallocating memory on the stack is typically fast because it involves simple pointer manipulations. Deterministic lifetime. The lifetime of stack allocated memory is deterministic and directly tied into the execution of corresponding function or block. The second one is dynamic allocation. Dynamic allocation involves the allocation and deallocation of storage space during the runtime or program or system. The allocation size of location can change dynamically based on the actual needs of process or data structures. Characteristics of dynamic allocation. Variable size. The size of allocated memory or disk space can vary based on the requirement of processes or data structures. It can be adjusted dynamically. On demand. The allocation is performed when a processor or data structure requires storage space, and it is deallocated when the space is no longer needed. And last one is runtime flexibility. The allocation can be adjusted during runtime based on the changing needs of processes or data structures. Dynamic allocation is commonly used in general purpose operating systems, database management systems, and other complex software systems. It allows efficient utilization of resources by allocating memory or disk space only when needed. However, dynamic allocation introduces complexity in managing the allocation and deallocation operations and may suffer from fragmentation issues if not properly managed. Example for dynamic allocation is heap allocation. Dynamic size. Heap allocated memory can have a dynamic size, meaning it can be allocated or deallocated at a runtime based on program requirements. Slower allocation and deallocation. Heap allocation and deallocation involve more complex operations, such as searching for available memory blocks and updating heap data structures. And last one is explicit deallocation. Heap allocated memory must be explicitly deallocated by the programmer when it is no longer needed. Failure to do so can lead to memory leaks, where memory is allocated but not freed.